Hi students, so this is going to be problem 26 from page 156 in your text. This is in your packet that we did in class called friction and free body diagrams. Problem 26, it says 2 workers are sliding a 300 kilogram crate across the floor. One worker pushes forward on the crate with a force of 380 newtons, while the other pulls in the same direction with a force of 350 newtons using a rope connected to the crate. Both forces are horizontal and the crate slides with constant speed. What is the crate's coefficient of kinetic friction on the floor? All right, so the first step, so I'm going to kind of try to track what I'm doing. So I'm thinking about my problem max. So I'm going to start by making a free body diagram. And it's asking me ultimately to find the coefficient of friction. So I know I'm going to be using the friction equation. So I have to think about how I will get there. Excuse me. The key word in this problem, and I don't know if you picked up on it, but the key word was that the crate is going to be sliding with a constant speed. So we know that anytime that we have constant speed, we know there's going to be no acceleration. And that means that there's going to be a 0 net force. So we know when I do this free body diagram, forces are going to be balanced both in the vertical and in the horizontal direction. So I'm going to be using that information now that I know that my forces are balanced. That'll help me figure out what my friction force is. So I'm going to find my kinetic friction force. And then I will use my equation. The force of kinetic friction equals mu, which is the coefficient of friction, times my normal force to calculate mu, or my coefficient of kinetic friction. So it's actually mu sub k because it's kinetic friction. All right, so that's kind of my problem map. I'm going to draw my free body diagram. I know that when I do that, I can figure out all my forces because they have to be balanced. Because I have constant speed, there's no acceleration. So I know I have balanced forces. And then after I do that, I have all the forces I need. That'll give me my friction force, and I can then plug that into the equation. I'll also have my normal force, and I can find mu. So step 1 was to draw my free body diagram. So I'm going to draw my crate. And so we have 2 forces on the crate. One of them is a tension force of a rope on the crate. The person's pulling on the rope, and the rope is pulling on the box. One is the person pushing on the crate, but they're both moving the crate in the same direction. So 380 newtons is one of those forces. 350 newtons is the other force. And so what other forces are on my box? I know that there's gravity. It gave me a mass. So I know that my mass was 300 kilograms. So my force due to, these are both force applied, right? Applied forces, I'm just labeling them so I remember what they were. This is going to be gravity. And so that is going to be equal to mass times acceleration. In the case of gravitational force, we always have 9.8 meters per second squared as our acceleration. You can use 10 if you prefer. It makes that math easier. And my mass for this problem is 300 kilograms. So I get 2,940 newtons for my gravitational force. Now, is my box moving up or down? Nothing in the problem indicates that the box is accelerating upward or downward. So that means my vertical forces must be in balance. So I know that my normal force is going to be equal to my force due to gravity. Again, this is a box on a flat floor. We'll talk about normal force on an incline. That's our topic next week. But for now, we're on the flat floor. Our force, normal force, is going to be equal to gravity, and it's going to be 2,940 newtons. Now, is there any force moving back in the opposite direction? So we know that the direction of motion, sometimes just putting a little velocity vector above, not on my free body diagram. This is just forces. All these arrows are forces, but I could put one up here. I know that my box is moving with constant velocity in this direction, the direction of the applied force. And so anytime that I have motion, frictional force is going to oppose the direction of motion. So my kinetic friction is going to go backward. And in this case, because my velocity is constant, I know that forward and backward forces have to be equal. So my total forward force here, my F net forward, is going to be 380 plus 350, and it's going to be 730 newtons. And so if the velocity is constant, there's no acceleration, my forward force here has to equal my backward force. And so that frictional force is also going to be equal to 730 newtons. So did I do step one? Yep, I have a complete free body diagram. Did I complete step two? I thought about constant speed. I figured out using this information that there's no acceleration, there's no net force, the force has to be balanced. I was able to find the force due to friction. So I finished the first part of step three. Now I just have to use the friction equation to find mu. And so I'm going to solve this equation for mu. So again, if I have force of kinetic friction equals mu times normal force, I want to solve for mu. Who's in the same side as mu? Well, normal forces, what's the math holding them together? It's multiplication. I do the opposite math, so I'm going to divide by normal force, and I have to do the same thing on both sides to keep them equal. And so I'm going to get the coefficient of kinetic friction, mu sub k, is going to be equal to the kinetic friction over the normal force. Kinetic friction force over normal force. So my kinetic friction force was 730. And my normal force was 2,940. And so when I do that math, I get 0.25. All right. I'll leave it there for just a second, and then I'm going to stop.